The universe is talking, all the time, in a language of light and gravity, of particles and waves. Most of its speech is familiar to us now. We can read the ancient light from the first stars. We can hear the gravitational echoes of colliding black holes. But sometimes, the cosmos whispers a secret, a fleeting message from the deep dark that we just can't quite decipher. Imagine listening to a cosmic radio, scanning the channels between the stars. Suddenly, for a split second, a blast of energy screams through the static. It's a signal, powerful and sharp. And then, just as quickly, it's gone. This isn't science fiction. This is a real cosmic mystery happening right now, above your head. They are fast, lasting for only a few milliseconds, a thousandth of a second. That's shorter than the blink of an eye. They are also bursts of radio waves, a type of light our eyes can't see but our radio telescopes can. These aren't gentle hums, they are colossal shouts. In that tiny fraction of a second, a single FRB can release more energy than our sun does in an entire day. Imagine all the sun's power focused into a single momentary cosmic thunderclap. Think about the journey that signal has to make. It travels for billions of years, crossing the emptiness between galaxies. It navigates past stars, through clouds of gas, and around gravitational fields, carrying a story from its distant, unknown source. By the time it reaches us here on Earth, it's a whisper of its former self, a faint echo of a cataclysmic event that happened long, long ago. Catching one is like trying to catch a single, specific raindrop in a global thunderstorm. Yet, we have caught them, and each one we catch deepens the mystery. The story of the first fast radio burst begins not with a bang, but with a search through old data. It was 2007. Astronomer Duncan Lorimer asked his student, David Narkovich, to sift archival Parkes data. They weren't looking for anything strange. They were hunting for pulsars. It was painstaking, like a needle in a digital haystack. The Parkes telescope had stared at the Magellanic Clouds, two of our neighboring galaxies. It recorded mountains of data. Just another day of cosmic accounting, or so they thought. Suddenly something appeared that made no sense. Among familiar crackles and pops was a signal of immense power. It lasted less than 5 milliseconds. A spike so bright and brief they suspected a glitch. Maybe interference from our own planet. A microwave oven in the observatory kitchen? Or a stray satellite signal? It had the hallmarks of a signal that had traveled very, very far. The key was dispersion. Radio waves encounter stray electrons as they travel. Lower frequency waves get slowed more than higher frequency ones. Imagine runners on a track with hurdles. Faster runners clear them easily. Slower runners get held up. By the finish line, the group is spread out. The same happens to a radio burst. High-frequency waves arrive first. Milliseconds later, the low-frequency ones follow. That delay, the smear, tells us travel distance. The burst's dispersion was huge. It implied a journey of billions of light years, originating far outside the Milky Way. It came from when Earth was young, long before dinosaurs, before complex life had truly taken hold. This wasn't a glitch. This was real. Something new. They called it the Lorimer burst. Its discovery birthed a whole new field of astronomy. One accidental find in a dusty archive opened a new window on the universe, revealing a phenomenon we never knew existed. How do you catch an invisible signal faster than the blink of an eye? You build a cosmic net. These are radio telescopes, but not traditional ones. Since the bursts are rare and unpredictable, astronomers built telescopes with incredibly wide fields of view, like switching from a laser pointer to a floodlight. Telescopes like CHIME in Canada don't steer. They simply stare at the sky, and when a burst flashes, powerful computers catch it. What makes fast radio bursts so strange isn't just their power, but their behavior. At first, we thought they were all one-off explosions, but then we found repeaters, sources that flash again and again. This changed everything. A single cataclysm can't happen twice. So this implied a long-lived engine. But the mystery only deepened. We found one repeater in a turbulent star-forming nursery, another in the quiet suburbs of a galaxy like our own. Then we found one that acts like clockwork, bursting for 4 days and going silent for 12 on a strict repeating cycle. The sheer variety is baffling. So, what makes these signals? We are cosmic detectives, and the leading suspect is a magnetar. It's a dense stellar corpse with the most powerful magnetic fields known. A starquake on its surface could unleash the colossal energy of a fast radio burst. The theory got a huge boost in 2020 when we detected an FRB-like signal from a magnetar in our own galaxy, a smoking gun. But does this explain everything? Other exotic ideas exist, from colliding black holes to extraterrestrial signals. As scientists, we must keep an open mind.